Okay, everybody, in this video, I want to go over some more with the Sig Figs and the rules with addition and multiplication. I know we've been getting some issues with this. I've been getting questions about it, saying that it's hard to understand. So I'm going to try to do a video that encompasses all of it, that hopefully helps you out a little bit. And this time I'm in front of you. If you still have questions after this, please feel free to contact me with those questions. The first thing going over again with this video is going to be the actual number of Sig Figs. Remember the first and foremost rule that all non-zero digits, 1 through 9, are always significant. So in this example here, the 9, the 1, and the 1, they are significant. The hardest thing with significant figures is deciding the zeros. And there are different rules. There are trap zeros, there are leading zeros, there are trailing zeros, and there are right zeros. In this example, this zero right here, right there, that is going to be trapped. That zero right there is trapped because it's in between non-zero numbers. This zero on the end, not a leading. It is a trailing zero. It comes at the end and there's no decimal place or number anywhere after it. So what we have here is the trapped zero, the 9, the 1, and the 1. So all four of those, they are significant. Trailing zeros are not significant. They need to be there as placeholders, but they're not significant. That means this number, 91,010, has 4 Sig Figs. It has 4 Sig Figs. Let's go to the next example. 918.010. The 9, the 1, the 8, and the 1 are significant. So we know we have at least 4 Sig Figs. We have to decide for these zeros. This zero right here is trapped between an 8 and a 1. So that is another trapped zero. It is significant. So now we have 5 Sig Figs. We have to decide about this last zero right here. It comes at the end, but there is a decimal point right here. What this zero is a right zero. It is to the right of a non-zero digit and to the right of a decimal. That is a right, and it is also significant. So this number, 918.010, would have 6 Sig Figs, or significant figures. Moving on to 0.00030. We have these 3 zeros out front. All 3 of these are called leading zeros. They come before all non-zero digits, but they do come after the decimal place. Leading zeros are not significant. They are placeholders and they're needed, but they are not significant. That 3 is significant. This zero here is to the right of the 3 and to the right of the decimal. That means it is a right zero. That means it is significant. So this one has 2 Sig Figs. Going down to the next example. 9,101.0. Significant, significant, significant. Now we have to decide the zeros. This zero right there is trapped between a 1 and a 1, so it is significant. This zero here that comes after the decimal, it is to the right of the decimal and to the right of a non-zero. It is a right zero. So it is significant. That means there are 5 sig figs here. 5 significant figures. In this example, we have another 0 that comes before all the non-zeros, but after a decimal. It is a leading 0 and is not significant. That means this example only has 2 sig figs. 1, 2. In the last example here, we know 1, 9, and 1. They are significant. So now we have to decide about all the zeros. This 0 right here, it is a trapped 0 between 1 and 9. It is significant. This 0, and this 0 is trapped between a 9 and a 1. So all 3 of those are significant. They are trapped zeros. This 0 at the end comes to the right of a non-zero and to the right of the decimal. It is a right 0, and it is also significant, meaning this number here has 8 sig figs. Moving on to the addition and subtraction. This is what you get when you plug them in straight into the calculator. These are not rounded yet. What you have to make sure is using the proper rule. With addition and subtraction, it's the same rule. You can round your answer to the least number of decimal places in your problem. So for example, here we have 2 decimal places, here we have 3. So 2 decimal places, 3 decimal places. That means our final answer can have no more than 2 decimal places, meaning we would be rounding right here at this 0. We look after it and it's a 1. A 1 does not round anything up, so the answer is 27.00. 1 decimal place, 2 decimal place. Same here. It doesn't matter if there's 3 things being added up. This has 1 decimal place, 2 decimal place. This has 0 decimal places. So the least number that we can have is 0. So we're rounding right here at this 3. We look after it, right after that decimal, to 2. So it does not do anything. So 1,203 is our final answer. We want the least number of decimal places that are in the problem. That's all that we can have in the answer. Let's look at this next example. 0.008 plus 0.05 gives you 0.058. Here we have 2 decimal places. Here we have 3 decimal places. So the number of decimal places in your final answer can only be 2. That's the least. So we're going to round right here at the 5. 1 decimal place, 2 decimal place. So the final answer is 0.06, because the 8 rounds up to 5. Now, I did get asked this question the other day in class. If you wrote 0.06, would that be wrong? No. That answer is also correct. You're not adding decimal places, and this 0 out here is not significant, so it doesn't change anything. If you were taught to write it like this here, that is fine. I was always taught to write it like that, and I'd never put the 0 out in front. If you put this 0, that's okay. It's not incorrect, and I will grade it whenever I see it in your homeworks. The final one. Here we have 0 decimal places. Here we have 1 decimal place. So the answer can have no more than 1 decimal place. Sorry, can have 0 decimal places. 0 decimal places. So we're going to round right here. We look after, and it's a 7. The 7 rounds the 2 up, so the final answer is 113, 113. And then from multiplication and division. Multiplication and division have very similar rules to addition and subtraction. But in addition and subtraction, we were looking at the number of decimal places. For multiplication and division, we're looking at the total number of sig figs. Your final answer can't have more sig figs than what are in the problem. For example, here, this 0 is not significant. But the 1 and the 0 are, because this is a non-zero, this is a right. So there's 2 sig figs. This 0 is trapped, so it is significant. That's 4 sig figs. So the least number of sig figs is right here with 2. That means when we round this, we're going to round at 1 sig fig, 2 sig figs. And always read your sig figs left to right. So we get an answer. 0.81. Because there's nothing to round it up after. We still look after, and that's a 0. The 0 doesn't round up. So the final answer is 0.81 or 0.81 is also correct. Division. Make sure with division, I want you to be able to see this. I use this slash symbol. We do not use that symbol. We don't use the regular division symbol here. We're going to use the slash, is how you're going to see me write. If I don't erase all my work. So 1.678 divided by 0.42. You get this really big number here. This number is really precise. These are not as precise. The reason this is more precise is all these decimal places. We can't actually measure all those decimal places. So again, we have to round at the proper number of sig figs. We know 4 and a 2 are significant, so that has 2 sig figs. 1, 6, 7, and 8 are all significant, so that has 4 sig figs. So the least, or the number of significant figures we can have in our answer is 2, because that's the least number of sig figs in the problem over on this side. So when we round this, we're going to round right at that 9. When we look after it, there's another 9. This 9 rounds this 9 up, but that also rounds up to 3. So your final answer comes out to 4.0. Yes, you need this 0 with it because it is to the right of the decimal, to the right of a number, and it makes a right 0. That is 1 sig fig, 2 sig figs. Both of those are significant, so you need them both. Make sure you pay attention to these rules. We do need practice with it. You will have a quiz on this material coming up on this upcoming Friday. The purpose of this is to make sure that we have precise measurements. We can't have more precise measurements in the answer than we do in the problem. And this is determined over here in the problem by your measuring devices. And we're going to have to pay attention to those sig figs. If you have any questions on these sig figs, please don't hesitate to ask me. Thank you, everybody, and I hope you have a wonderful day.